Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Hope so. You all are doing really great. So students, in this class we are going to learn about the Kepler's law of planetary motion. There are three laws. But before that, you know very well, in solar system, sun is there and the planets are there. And what we know, planets revolve around the sun and sun is where? The sun is at the center of the solar system. Is it? So Kepler law is based upon the motion of the planets, like how the motion of the planet takes place around the sun, what are the laws are involved. Same law can be applicable when the satellite is revolving around the planet, like you know very well the moon is one of the satellite of the earth, is it? Similarly, you know very well lot of satellites are there for the Jupiter, is it? So all these things we can understand very well by understanding the Kepler's law of planetary motion. Okay students, so let's start the video and let's learn very well the three laws of the Kepler's motion. Okay students, so let's start the video. So students, here you can see very well the first thing is water. The first thing you can see very well, the Kepler's law of planetary motion. Basics. What is the basics? See please. Kepler's law of planetary motion are three scientific laws describing motion of planets around the sun. As I told you, is it? After that, see please, these laws are also applicable to the satellites revolving around the planet. Is it? That means what is there? Planet around the sun also. Same basic laws. Even satellite is revolving around the planet also. Same basic laws. Okay. Now let's see the first law. What is the first law? Is there? Kepler's first law. That is called the law of orbits. And what is this? See please. All planets revolve around the sun in elliptical orbit, having the sun at one of the foci of the orbit. Now you can see very well all these things, is it? So you know very well two kinds of path is possible. One is the circular orbit, one is the elliptical orbit. But in this one we are going to learn about the elliptical orbit. If elliptical orbit concept is very clear, circular orbit is a very easy. Okay students, so this is the first law, law of the orbits, elliptical orbit. Where is the sun? Sun is at one of the focus, because in ellipse how many focus is there? Two focus is there. Okay, so sun is at one of the focus. And where is the planet? The planet is revolving around the sun. In which orbit? Elliptical orbit. Now very general thing we are going to see. Okay, now next one, students, see please, basic concepts of the ellipse, because before learning this law we should know very well about the ellipse. In maths we will study and we know also some of the basics, but still we will learn to understand this topic very well, especially the second law of the Kepler. Okay, so see please students, see here please, basic concepts of ellipse. So here what is given here? See, when a particle moves with respect to two fixed points in such a way that sum of the distances of it from the two fixed points is always constant, then the path of the particle is an ellipse and the two fixed points are called foci of the ellipse. Why foci? Because two focus is there, is it? So students, here we are going to see equation of the ellipse. You know very well, like equation of the straight line, equation of the circle. Based upon that, there is the equation of the ellipse also. So ellipse looks like something like this. This is the ellipse here. Okay, so this used to be the x-axis and here this used to be the y-axis. Okay, and this is used to be called the center of the ellipse. Okay, later also we are going to learn in a detail, but I am just telling you here, this is called the major axis, because this is looking big, 2a. So this is a, that means a is semi-major axis, a is also semi-major axis. Similarly, if I talk about here the vertically, so here what will happen that here, this total distance is used to be how much here? This total distance is used to be 2b. That means this is b and this is also b, this is b, this is also b. So this a is called semi-major axis and b is called semi-minor axis. So based upon that, there is the equation of the ellipse is there. Now let me just write here equation of the ellipse. You know very well, x square by a square plus y square by b square equal to 1. This is the equation of the ellipse. Okay, now we are going to learn about this ellipse in a somewhat detailed manner here. Okay, so you see students, here I have drawn somewhat bigger diagram. Okay, so let me first write here some points. Now, so here I have taken, this is, let's take, this is the point A, this is the point A, okay, this is point B, okay, and here I have taken, this is point C, and here I have taken, this is point D, okay. And as I have told you very well, what is the major axis, what is the minor axis. So if you will talk about here this AB overall, this AB is called the major axis, and this AB length how much here? This AB length is the 2A, okay. Similarly, this CD is called what? Minor axis here. That means minor axis. How much length? CD length will be how much here? 2b. Okay. So based upon that, students, we know very well this length here to here. This length will be what here? This length we should know very well. This length is the A. A is called the semi-major axis. Okay. Similarly, if I talk about here the vertical direction, this length is what? B, and that is called the semi-minor axis. Okay. Now students, here what will be there? The two focus will be there. One focus will be here. Now this is the first focus, F1, and here also focus will be there, F2. I am talking about the symmetrical ellipse. That means what will happen? Remember that here one thing, here also this BF1 and this AF2 will be equal. What I am telling? BF1 and AF2 will be equal. Now we know very well. Now students, after that, here I am going to take here please. Now, so let's talk about the sun. Where is the sun? The sun is at one of the focus. Now let me draw here the sun with the which color? Okay, let's take sun. Good color is okay. I am taking green here. Already is there green. Now here sun is there. Now this is the sun. So sun is at one of the focus. And where is the planet? The planet is here revolving. Now let's take some, for example, let's take planet is here. This planet P will revolve. On which orbit? Elliptical orbit, like this. It will keep on revolving here. Okay, so can you guess very well at which point planet is the maximum distance from the sun? Is it? Can you guess very well? That is the point A. When the planet is here, that time it is maximum distance from the, this is the maximum distance from the sun. Now the planet is here. Okay, this is called which distance? That is called the aphelion distance, maximum distance. So what is called this distance? This point is called aphelion. Okay, and this distance, okay, this distance, let me draw here. Now this distance is called what? This distance is called aphelion distance here. Okay, RA, aphelion distance, RA, aphelion distance. Okay, now can you see very well at which point the planet is the very near to the sun? This here, at point B. Okay, this is called which one? This is called, this point is called perihelion. Perihelion, P-E-R-I-H-E-L-I-O-N, perihelion. Even sometimes this is called apogee and this is called perigee. Okay, and this distance, students, let's see here please, this distance, this one, this distance is called RP. Okay, very clear. Now students, after that we have got what is the aphelion, what is perihelion, all these things are clear. But now we will see some of the very basic thing that will be required here. So students, you can see very well according to the definition of the ellipse, what is there? The distance, the two distances from the fixed point is always constant. So see here please, here this is planet P here and this distance here, now PF1 and PF2. So what will happen according to the basic definition of the ellipse? What we can tell here? Just let me write here please. Here we can tell this PF1 plus PF2, it will be constant even when the planet is at point A also. So what will become here? AF1 plus AF2, even when the planet is at point B also. Then what we can write here? BF1 plus BF2. All these distances will be constant. And this distance will be how much here? This distance will be 2a. Is it? Remember that here, very basic thing. After that students, if I talk about here, this RP, RA and the small a relation. So you can see very well this total distance how much? 2a, because I told you what? AB is 2a. And you will see very well RP plus RA is what? 2a. So students, here I am writing here again. You can see very well this RP plus RA is equal to how much? 2a. Hence, what is A? A is given by RP plus RA by 2. Okay, students. So this A is called what? This A is called, as I told you very well, the semi-major axis, or even this A is called mean radius also. Now, why mean radius? Because the distance of the planet from the sun is keep on changing. Even from the center also. Planet distance is keep on changing. Okay, that's why this A is called what? Mean radius or semi-major axis. So I hope so. All these basics are very clear. This is very, very important to understand the Kepler's law. Okay, see it very well. You can take the screenshot also. Okay, now students, we'll go next one here. See, now, eccentricity. What is the eccentricity? See please. The ratio of the distance between two focal points and the length of major axis is called eccentricity here. Okay, so eccentricity E. Distance between two focal points, how much here? F1, F2. Now, one focus is F1, another focus is F2, F1, F2 by AB. Okay, now we'll go to the back side here. What is the AB length? AB length is 2a, and F1, F2 distance, let's take for example, I have taken here, this distance is a dash and this distance is also a dash. So can you see F1, F2 how much here? 2a dash, is it? So it will become here F1, F2 means 2a dash, AB means 2a. So what will happen that here? This 2 cancel. That means what we can write here? That means we can write here a dash is AE. A dash is how much here? A dash is AE. Okay, what is E is the eccentricity here. Okay, after that, students, we are going to see some extra points here. The first point is that relation between semi-major axis, that means A, semi-minor axis, that means B, and eccentricity E. That relation will be how much here? B square equal to A square 1 minus E square here. Okay, and this eccentricity for the ellipse is used to be E greater than 0 and less than 1. Okay, but if in case this ellipse is becoming circle, so for circular orbit, which orbit, students? Circular orbit. For circular orbit, you know very well, A will be equal to B. That means eccentricity value will be how much here? 0. Please remember that. Okay, this is the first extra point. Next one, students, we can see here, please. Now, I am going to find out the distance RA. So in the previous diagram, can you see what is the RA? No. This RA. RA is how much, students? RA. We can tell RA here. OA plus OF1. Again, I'm telling this OA plus OF1 is called what? RA. Is it? Again, I'm writing here OA plus OF1 is RA. What is OA? A. And what is OF1? Just see the diagram. Backside you will see here. A dash. And you know very well here, this A dash means AE. We have seen here. That means we can write here this RP is equal to A 1 plus E. Very important for the competitive point of view. Okay, RA, this is RA. Okay, RA. Now students, after that, if I talk about here next one, RP. Now let's go backside, students. What is the RP here? This distance is the RP. So can you see very well, this RP is given by OB minus OF1. Again, see here please, OB minus OF1. Na? See here please, very well, OB minus OF1. Okay, so here I can write here, see please, OB minus OF1. That means it will become here A minus A dash or A minus AE, or we can write here this RP will be A 1 minus E. Okay, students, so all these things you have to remember, right here RA you have to remember, RP you have to remember, and backside this A also you have to remember to understand this law in a very easy way. Okay, students, so all these things are very clear. Next one, now we are going to learn about the Kepler's second law. After learning all the basics of the ellipse, we are going to learn about the Kepler's second law. Okay, so let's see please here. A line joining any planet to the sun sweeps out equal areas in equal interval of time. That means, what is the meaning of this? That means the aerial velocity of the planet remains constant. Remember that aerial velocity of the planet will be constant. So even I can tell here please, according to this, what we can tell here? Just 1 minute. So according to this, what will happen? This dA by dt will be what? This dA by dt will be constant. Okay, so see please again, according to this law, if a planet moves from M to N in time interval T1 and from P to Q in time interval T2. Okay, so just let me take here the planet. Let's take planet is here. First, the planet is moving where to where in the question? M to N. Means in a concept, M to N. And after that, it is moving where to where? P to Q. Let's take for example here I have taken. This is P and somewhere this is Q here. Okay, so just let me write here please. This is the distance. Sun will be here at one of the focus. Sun will be here at one of the focus. And after that, this let me write here all these things. From here I will write here. Okay, so you can see very well here what is there. Here the sun is there. Sun is there. Okay, so students, let's take here this area and this area. Okay, let's take for this one, the time is T1. Let me change here the color. Okay, okay, let's take here area is A1 and time taken is T1. Okay, in second situation, let's take area is A2 and the time taken is T2. So what will be same? Aerial velocity is constant. What we know? dA by dt is constant. constant, is it? So from here we can tell very well this A1 by T1 will be equal to A2 by T2. What will be there? Aerial velocity will be constant. Later we will see very well angular momentum will be also constant. Okay. So let's see here please. Next one is students, see. Relation between aerial velocity and angular momentum here. Okay, aerial velocity dA by dt, angular momentum L. Okay, so see please, let a planet moves from M to N by subtending angle d theta at focus in time dt. Then area of the curved triangle can be calculated as here. Okay, so as I have told you very well, let's take here. Here I have sun. Okay, and the planet is there. Let me draw here the planet. Planet is moving where to where? M to N. So let's take here, this I have taken M, and somewhere this I have taken N. Okay, and let's me take here the distance. Let's take here this distance here. Now, so planet is moving here to here, M to N. How much angle it is making? How much angle it is making? See please, this angle is d theta, and how much time taking? The time taken is dt here. So students, remember that one thing here, very small angle is there d theta, and even you can consider this angle is theta here. Now, so at any instant what is happening? The planet is at point M, angle is theta, it is keep on moving, angle theta is keep on changing, but we are seeing very small angle d theta. So M to N d theta angle is there. Okay, and remember that one thing here, this is called this distance even called here the position vector, position. Now, so we can tell here this is the R is there. Now, as I have told you very well, when it was at point A, RA, and when it was at point B, it was RP, distance of planet to the sun. Okay, so students, you know very well that area of the triangle. What I am talking about here, area, this area. Okay, so area of this curved triangle is given by, you know very well, what is the area of the triangle? Half base into height. Half base into height. Curved triangle is there. Now, curved triangle is there, so half. Base how much? Let's take here this. This H2 M is the height and M to N is the what? Base. So base means what here? Mn. Half Mn into height how much? I am taking here Sm. Very small triangle is a very small triangle. Okay, curved triangle. So here please here half. What is Mn? You know very well. Angle equal to arc by radius here. What we know? Angle equal to arc by radius. So arc means arc. Arc means angle into radius. Angle into radius. Okay, radius. So angle is what? D theta, and radius means r. That means this distance. This distance we can write here what? This distance will be r d theta. Okay, so let me write here. This is r d theta, and what is Sm? H2m. This is r. So see please very well. Half r d theta into r. Okay, we have got here. This is the area of the curved triangle. Now students, what I will do here, both the sides I will divide by dt because we need the aerial velocity. So dA by dt, and here also I have taken by theta. So what students, it will happen here, see please, this dA by dt, it will become here, see please very well, half into, we can tell very well here, r, no? This r I have taken here, and r into d theta by dt, this one here. What is d theta by dt? Omega, is it? So we can tell here half r and this thing, r omega, we can write here v. That means we can tell very well this dA by dt is equal to what? Half rv. Half rv. What is r? Distance of planet from the sun. And what is the v? V is the speed here. No? At different instants we are going to see here please. Okay. Now students, we can see very well, we have got na, dA by dt equal to half rv. No? So see please, we have got here what? dA by dt is equal to half rv. Okay. So from here we can get the first thing here. The first thing is what? Half rv. Can we multiply and divide by mm? So see please here, half multiplied with m, mvr by m. What is mvr? Mvr is the angular momentum. So we can tell here dA by dt is equal to L by 2m. What is L? Angular momentum here. Okay. So you know very well students, as aerial velocity. Which one? Aerial velocity is constant. What I have told you? I have told you dA by dt is what? Constant. dA by dt constant means what is constant? L will be constant. That means angular momentum will be constant here. Based upon that, we can draw one more thing here. One more thing we can draw here. See, as the angular momentum is constant, what is L? Mvr. The mass of the planet is not changing. So as mvr is constant, mass is not changing, so we can write here v into r will be also constant. So second law is very, very important. What is there? Aerial velocity constant, angular momentum constant, even r into v is also constant. Okay, next one, see. Speed and kinetic energy at perihelion and aphelion here. Okay, perihelion, aphelion. So you know very well, if I talk about here, no, here I have taken that here, no, just here was the sun, no, this was which distance, this was which distance here, aphelion distance, this was which distance, perihelion distance is there. Okay, and students, let's take here, if I talk about here the distances, this distance was how much here, RA, again I am drawing for you, this distance was how much here, RP, no, like this here. Let's take at point A, speed is VA, and at point P, speed is VP. Can you tell very well where the speed is minimum? You know, this distance is maximum because R into V constant. That means we can tell V is inversely proportional to R. So as RA is maximum, yes, that means this distance, this speed will be minimum. Similarly, this RP is minimum. So this distance, this means this speed will be maximum. Again, I am telling, listen to this. RA is max. So speed is minimum. RP is minimum distance from the sun. That means speed is the maximum. Okay. So we can tell very well, VP into RP is equal to VA into RA. Okay. That means we can tell very well, VP by VA is equal to RA by RP. Just see, go back side of the video, you can see very well what RA I have taught you, R1 plus E or A1 plus E. I have taught you A1 plus E. This is A1 plus E by RP, A1 minus E. So A and A will cancel. So we can tell here, students, this VP by VA will be how much? 1 plus E by 1 minus E. Remember that, directly they will ask in the exam. Okay. Next one is, students, if I talk about here the kinetic energy here. So kinetic energy, let's take here. Kinetic energy at perihelion and aphelion here. Okay. So here, students, what will happen that here, you know, half mv square, half mv square, half m, cancel. That means we can write here this Vp by Va whole square here. Okay. What is Vp by Va? This 1 plus E by 1 minus E. So we can write here, see please, 1 plus E by 1 minus E whole square. Remember that here both the relation, this relation and this relation, very, very important. You can see it very well. Okay. You can take the screenshot also as per your wish. Okay. Next one is, students, first law we have understood. No? Second law we have understood. Second law is somewhat complex. Third law very easy. See please, the square of the time period of revolution of any planet around the sun in elliptical orbit is directly proportional to the cube of the semi-major axis of its elliptical orbit. So very simple. If the time period is t for the revolution of the planet and semi-major axis how much? A. So according to this, they are telling that here square of the time period is directly proportional to what? Cube of the semi-major axis here, A cube. Okay. So after that, students, this thing we have understood very well. Now, as I have taught you very well, what was the A? A was RP plus RA by 2. In the question they used to ask, what is A? What is A? A is the mean radius. So if I will put here the values here, students, see please, this will become here T square directly proportional to RP plus RA by 2 cube. So 2 cube will be constant. So we can tell here this T square directly proportional to RP plus RA power 3. Okay. If I will write here the T, for example, T. So T will be directly proportional to RP plus RA by 3 by 2. Basic tool of the exponent here. Okay. So this is for which orbit? This is for the elliptical orbit. Okay. Now under the note, if we see for the circular orbit. Which orbit, students? The circular orbit. In circular orbit, what will be there? Distance of planet from the sun will be always constant. That means what will happen that here? There is no RP, RA and all that here. We can tell even RP equal to RA is water R. So as the distance is not changing, speed of the planet in the circular orbit will not change here. Again, some extra I am telling that here this V will be constant. in case of elliptical orbit, r is keep on changing, so v's keep on changing. Now perihelion, what was there? Perihelion, it was maximum, aphelion, it was minimum speed. But in case of circular orbit, the r will be constant, v will be also constant, speed will not change. Velocity, because direction is changing, velocity will change, but speed will be constant. Okay, so based upon that, if we'll see here all these things here, so for the circular orbit, it will be t square directly proportional to r cube here. Okay, or even you can write here t directly proportional to r to the power 3 by